We have on stage Matt from Komaya Technologies. Let's welcome him properly, and thank you.
Thank you. Hi, welcome Bucharest. So my friend Boss told me that Romanians love to talk about money, so that's why I chose this title, even though it's not the main topic. So I was like, that would be the best effort to convince everybody to wake up at 8 in the morning. Hey. So I'm French, I am based in Dubai, and I currently have a cybersecurity startup focused on memory-based technologies, mainly for forensic and incident response. And before that, I was the founder of a startup called Cloud Volumes, and we were focusing on application delivery. We got acquired by VMware 2 years ago. So in 1998, when people like Josh were still doing technical stuff, you had Mudge was talking to the US Senate, and back then he was 27, and he was explaining to the US government the problem with security. Basically, he just told them, if you're looking for computer security, then the internet is not the place to be. So what has changed 20 years later? Well, if you've read the news lately, it seems like not much has changed. I guess you guys probably heard about Mirai, that botnet that targeted a bunch of websites. And if you look at the technical aspect of it, it was just like using default password on embedded device, which is like, if you think about it, that's pretty lame, you know. If you're like your main attack vector is just like using default passwords, and if you manage to shut down a country like Liberia, even though they probably still live in the 80s from a technical point of view, still. And a few years ago, you have people like Charlie Miller giving presentation at Black Hat, explaining how to hack the firmware of batteries to make them explode. And if you look lately over the past few months, you see like manufacturers are just like putting like phones at the market with the same risk, except like you don't even need like an attack vector for it, just like a regular risk because of bad manufacturing. So if you look back, basically the problems over the past 20 years are still the same. Software still have bugs, except like now if you look at software, it's going to be what you're going to have on the operating system layer, but also now with the Internet of Things, you're going to look more and more at the firmware vulnerabilities. People are looking more and more at hardware vulnerabilities. And on that side, especially with firmware, if you look at the type of vulnerabilities you're going to find, pretty much exactly the same type of vulnerabilities that you used to find in the 90s or early 2000s. Bad configuration is still a problem. If you think about Mirai, like default passwords are still like not that many people are going to be like using Windows 10 now. A lot of like critical infrastructures are still running with like Windows XP, Windows 2000. So what has happened over the past 20 years? We started to see a huge increase in companies. So if you look at this graph, basically that's the number of companies that had been created over the past 20 years for information security. So the companies like here are from Crunchbase. So basically all those companies either were part of a significant press release or did like a fundraising. So as you can see, over the past 20 years, you see like a huge increase for like security companies. And especially after like 2008, like the number of companies like almost doubled. So you had like the post like Snowden and Stuxnet effect. For For fundraising, so more and more security companies are doing like fundraising. As you can see, the increase in companies like seeking for like capital before starting working on a new product is significantly bigger. So compared to like 20 years ago, where everybody was doing like computer security because it was fun, you know, now it's becoming more and more of a business and a commercial institution. So if you compare like 2002 with like 2014, it multiplied almost by 7. So, which is quite significant, because if you translate that into dollars, the amount of capitals that had been raised over the past 20 years for like security companies, as you can see, is like close to 40 billions, which is it's quite decent, you know. Because if you think about it, if you want to be like a black cat and go after money, so far your best attempt was probably what happened in Bangladesh with the Swift network attack. And if you look at the return on investment, the risk, how much they managed to go out, you know, it's still far from those numbers. So when I initially published this blog post a few months ago, I was like, well, if you're looking after money, if you're in security, well, you don't necessarily need to be a bad guy. A lot of people are like, oh, but it depends on the opportunities and everything. But if you look at the numbers, you know, if you do like a company like FireEye, you're gonna make way more money than if you're doing a botnet like Mirai, you know. So if you look over the past 6 years, you can see like the increase of like investment being done in security. So there is more and more attention given to security now. And so that's the transformations that we have seen in the security industry over the past few years. So whereas like 20 years ago, like it was mainly like people were like passionate about the industry, now people are more and more like business oriented, which is one of the big difference. Even though the if you look at the big picture, the problems are still the same. If you look at acquisition, so US-based company are like the top acquirer. So they're gonna be first with almost like 600 companies acquired over the past 20 years, and then you see a huge gap with other countries, where you're gonna have in number 2 like Great Britain and then Canada. And for startups, so basically, same thing. Most of companies are like US-based, and then you can have Great Britain and Israel, where you see more and more security companies coming from Israel. So, like now the question is, are like US-based people like the only people who can actually solve security? What's doing people outside of the US? Because if you look at security from as a market or as a community, if you have been to security conferences, you're going to see it's not necessarily true, because you're going to see a lot of like interesting research done by people who are like not necessarily based in the US, people who are doing projects like GR security packs. Some of those contributors are not even based in the US. But if we look at the market, at the numbers, you see it's mainly led by the US. So what has really changed in 20 years? Well, we have seen like the numbers are like more and more important for security. Maybe like more awareness, because like now if you talk to your parents about security, it's going to be like more sensitive to it. Security is more part of the culture now, even though if you look like 20 years ago, the Hackers movie was like a big flop. Whereas like now, the main actor of like Mr. Robot just got like an award. So same problem, same history, but just the public is reacting differently to it. Like people now are like more sensitive to the issue. And if you look closely on what's happening, you're gonna start to see also patterns. because the innovation that we see in security is not necessarily as innovative as what we would like to think. There's many people who used to speak at conferences like 10 years ago, and now if they go to conferences, so we're like, oh, what's being presented now is not as technical as like 10 years ago, where people were already talking about like SMM rootkits and all those things, and now people will mainly be talking about like web tokens, hijacking. And if you look from a product point of view, now like the current focus is around like EPP and EDR, so endpoint protection platform and endpoint detection and response softwares. And according to Gartner, it's going to consolidate, and the main goal is to do like next generation antivirus. So basically, for like the past few years, everybody was like, oh, like antivirus and firewalls are like basically like useless softwares. Antivirus are like mainly based on signatures, it's not reliable. But what comes out of it is just like next generation antivirus. So if you look at it as a pattern, like the innovation from a product point of view from the market is not that significant. So what has really changed? So now everybody's talking about cyber, and the US candidate even like called it like the cyber. Now it's becoming like many a political problem. We started to see like more and more like nation-state attacks where like nations are like pointing fingers at each other. The problem is becoming more and more expensive. So like JP Morgan, for instance, reported to be investing like $500 billion in cybersecurity for various like services and solutions. So it's quite decent if you like look at the money being spent in security now compared to 20 years ago. A lot of the cool things that we have seen over the past few years is that many of the operating system vendors killed a bunch of different type of bugs, which so far was one of the most effective way to protect their customers. Because every time you see like an operating system vendor like Apple or Microsoft killing like a bunch of bugs or adding like a security mitigation, it's increasing the difficulty to exploit a bug or to find a bug exponentially. Whereas like monthly patches like Tuesday, Microsoft Tuesday, are like more incremental in terms of resolving a problem. Enterprise and more reactive to security. So we started to see like people talking about bug bounties. Some enterprise have their own like bug bounty program, where basically if you are like Joe in your living room, you find a bug, you want to report it. More and more like companies are going to have a program where you can report it, and where they're going to be coordinating with you to patch it, which is a big change, because if you did that 15 years ago, which a lot of people would not even think of reporting a bug, like the company would just try to sue you. So you have like companies like Bugcrowd, HackerOne, or people like just buying from the black market like Zerodium. So if you look at exploitable vulnerabilities, so this is a flow chart for Microsoft, which is quite interesting, because if you look at the number of like security vulnerabilities patched per year, you're gonna see like a significant increase in it. So what does that mean? Does that mean that Microsoft just like added more bugs to the software every year? No, it just means that Microsoft was more efficient at finding bugs internally, or that people were reporting more bugs to Microsoft. So if you look at 2015 compared to 2006, the number of bugs being patched per year had been multiplied by 4, which is quite significant. And if you look on the right, so the number of exploited vulnerabilities within the first 30 days decreased significantly. So that's one of the rare measure of success for securities that we can relate to in the market. So as you can see, 2015 15 compared to 2010, it went to 61 to 15 bugs exploited within the first 30 days. So that's quite a good decrease, and the rest will be mostly non-exploited, at least none to Microsoft. So for last year, you would have almost 400 vulnerabilities that were not exploited, and only 15 being exploited. So like I was saying before, one of the best change that we see is when a vendor is basically killing a class of bugs, because you're gonna see over the years like new trends in terms of exploitation. Like let's say hip spray used to be really popular like years ago. Now people will not even use it anymore. Why? Because well, it's easily detected now. So stack corruption, it's gonna be like really rare to find like stack corruption in 2016. Use after free were like a big trend in 2013, 2014. Now the number of bugs like that being exploited in the wild is significantly lower. So you can see it had been like divided by 3. And you're gonna see like new type of bugs appearing. So when it comes down to exploitation, you're gonna see like new categories going away and new categories appearing. So what does that mean if you are an exploit writer? So basically it means your cost per exploit is gonna significantly increase. So when 10 years ago, it would take you around like 2 weeks to write an exploit, and one single person would be enough. Like now in 2016, usually it's gonna take you like around 3 months and maybe like few people. So if you think about it from an attacker point of view, if you're like targeting someone, if you need to write an exploit, it's gonna be a significant investment from you. That's why we see more and more quote-unquote nation-state attackers, because they have like unlimited budget, so they can afford to do that for multiple bugs. And if you want to learn security now, unlike like 10, 15 years ago, it's gonna be way more complex now, because you're gonna have to cover so many different like categories of security. And even if you focus on a specific field like software exploitation, what you're gonna see more and more is people being specialized on certain platforms, certain softwares, which is where you see on the market like iPhone 7 bugs being for sale for like $1.5 million. So if you look at this slide, you're gonna basically see like a timeline from 2006 to 2016. So over the past 10 years, if you would write an exploit in 2006, that would be like quite straightforward. You could just like trigger like a stack buffer overrun, override the return address, and then you would be able to execute your code. And then we started to see new security mitigations like ASLR, DEP in Internet Explorer, that was basically killing like hip spraying. People are using a 64-bit operating system now, so your address space is going to be much larger than on 32-bit, so hip spraying does not make any sense anymore. And if you look now, like the type of bugs you're going to exploit are going to be like arbitrary, like read and write error, which is pretty much like now. So if you read, you're going to see it's much more involved. So you're going to need to place an array at a predictable location. So usually you're going to need like a vulnerability where you can leak some addresses that you can reuse later on. You can change the, you're going to have to change the length of that array. Use arbitrary read-write to discover like a base address of a DLL, because now, because of ASLR, You don't know like the addresses like beforehand. Whereas like with Windows XP and Windows 2000, you knew all those informations because they were embedded in the binary itself. Then you're gonna have to do your rob payload. You're gonna have to corrupt a virtual table. Then you're gonna have to execute your rob payload. Then execute your native code. And after that, most likely you're gonna need to escape a sandbox. So as you can see, as a process, compared to before where you would just have like basically like 3 main steps, now it's gonna be like 10 different steps, and each of them is gonna be like 10 times more complicated than what you would have to do in the past. So like I was saying, basically, like if you look at security and what happened over the past 20 years, the problem are basically the same. Most of the significant innovations that we have seen mainly came from the operating system vendors like Apple and Microsoft when they started to add security mitigations inside the operating system. But now, what we see with the Internet of Things is like all those devices are just like devices from the 90s or early 2000s because in their firmware, all those security mitigations that you see, like ASLR, data execution prevention, are not present on the firmware of those new devices. So if you're going to start security now, most likely you would focus on those type of devices rather than trying to learn security like on mobile or desktop because of the complexity it represents. And if you look at the industry in general, you start to see like cycles on terms of like solutions and products that people want to buy. And even though, like I was saying, like the industry spent like close to like 50 billion in investment over the past 20 years, the problems are like exactly the same. And you start to see like botnet like Mirai that have been exploited all over just because of default passwords. So that's it for now. So I kept like 15 minutes for like Q&A. So we can start giving the microphone to people if you have questions.
Good morning. My name is Andra Zahariau. I'm from Handel Security. And I wanted to ask, you said that there's an increased investment in cost per exploit, but how does that collide with malware as a service, which has kind of lowered the barrier for entry for cyber criminals with less experience? Thanks.
Well, basically it depends on the complexity of what you want. So if you want like a really advanced malware, it depends who you're gonna be, you know. Like if you just buy it like on like a dodgy Russian forum, you're gonna get like the low-end price, and that's most likely gonna be something which is gonna be easy to detect. But then, if you want a custom malware, then most likely you won't be able to find it on the forum as a malware as a service. You're gonna have to do like a custom request for that, and then the cost is gonna be like pretty high. And same thing as a defender. If you want to like secure yourself, like what you're gonna have to invest in security, you're gonna invest in like in your strategy like on multiple different layers to make sure that if something is being missed out, that you can catch it later on by something else.
Hi, this is Lucian from the IDG News Service. I see all these anti-exploit mitigation technologies in modern systems, operating systems. They're nice. But how do we deal with the systems that have very long lifespans, like 15, 20 years, like in industrial cybersecurity, industrial controls and maybe even the ECUs in cars and power stations and things like that. Because most of those that are deployed today are already vulnerable to very basic attacks and they lack security. Well, let's say that the vendors are working on the very next generation of PLCs and those types of devices, and they get deployed over the next few years. How can we protect them, or can build in security now that will protect them from attacks that will be discovered 10 years from now, where we'll have a similar situation as we have now with the older devices?
So in that case, you have like two categories. You have like, like out of that operating system like Windows XP that don't even have support anymore, but that enterprise are still using. And then like you were saying, like for cars and auto systems, as an end user, there's not much you can do. Like if the vendor is not doing like, creating like a proper like life cycle to answer to that, as an end user, it's almost impossible for you to fix it. So this like can push like updates like remotely. That's what they've done like few times. But then if as a vendor you don't think of it, as a user, like there's not much you can do. And you're just gonna find like those like you were saying, like very basic vulnerabilities still being present in those new devices, which is quite sad. That's why like, like as users, like the best thing you can do is kind of like pressure vendors, showing them that it's important and that they care, so they should care. If you look at Ford, who called back like several like million cars because of some security vulnerabilities, it costs them money, but now it's more and more accepted from like vendors that basically there is a cost to security that they cannot run away from.